I'm Steve Mann and welcome to Paper Classroom. This is the first of our tutorials on the science module of the Level 2 Papermaking Technical Certificate. In this first module, in this first introduction, I'm just going to talk about the periodic table. Now, what we're going to do in this video is not actually in the Level 2 exam, but it's just a nice bit of background so that you know where things come from. I usually like to know where things come from. I can understand things a lot better if I understood how they started. Well, the periodic table is really just a way of organising a list of all the elements, so that by looking at the way that the list is, maybe you can get some insights into things like trends or whether an element may be missing or not. And the first person to attempt to do something like this was this guy here, Dmitri. And he worked on this problem between about 1817 and 1829. Now, many people think that science is a very exact subject. It's actually quite the opposite. Science is really an approximating subject, but you're making better and better and better approximations till you get nearer and nearer and nearer the truth. And we have an idea and we use it until it doesn't work anymore, and then we're quite happy to find a new idea to replace it and discard it. And there's no clearer example than the development of the periodic table to understand how science works. So, this guy in 1817, he noticed that calcium and barium and strontium had very similar properties. He also noticed that strontium, the atomic weight of strontium, was exactly halfway between calcium and barium. And it was about 10 years later that he also found another set of three elements, chlorine, bromine and iodine, and they had very similar properties as well. So this guy was the first person to come up with an idea, and he called it his law of triads. He believed that nature built these atoms in groups of three, and when you found these three, the middle one of them had properties that were an average of the other two, the ones each side. Well, that idea lasted for a while. People found other groups of three, but then they started finding groups that were larger than three. So this law of triads, which lasted for a good few years, we discarded because we found a better law. And this was a French gentleman, Beguier. In 1862, he was the first person who actually took all the elements that were known at the time and listed them by their atomic weight. Before, people were just looking at properties, but he said, no, we've got a good idea of what their atomic weight is. Let's list them by atomic weight and see what we can see. And he graphed this information, and then he put the graph around a cylinder, and one turn, as you can see there, one turn was equal to 16 divisions. So he found out here that lithium was slightly different from beryllium, which was slightly different from boron, which was slightly different from carbon, and around it went in this spiral. So that was the second idea of having a periodic table. This was the law of 16, or the law of the spiral law. Anyway, in 1863, John Newlands, who was an English chemist, he was also a musician. So because he was a musician, if you think about musical notes, they all occur in eighths. And one of the things that John Newlands found was when you were listing things by atomic number, sorry, by atomic weight, he found that every eighth element had very similar properties to the first one. So coming down here, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So he said fluorine in a way was similar to hydrogen, chlorine was similar to fluorine. Here we have bromine was similar to chlorine, etc. So this became the order of 8 rather than order of 16. So he was talking about the octet rule. So we had a first law that was the rule of the law of triads. Then we had this spiral law. Then we had this octet law. In 1868, Lothar Meyer, who was a German chemist, he came up with a table that was very slowly a little bit along the lines of what we've got today. But what you might notice if you do know the periodic table is elements like this, lithium, sodium, potassium, he had them going across, whereas we had them going down. Again, boron, boron, carbon, nitrogen, oxygen, fluorine, where we have those going across our table, he had them going down. And by this time there were approximately 50 elements known. His great rival was Mendeleev, and although he created this table in just before Mendeleev did, he created the table, but he didn't publish it. He sent it off to a friend to look at, and by the time the friend got back to him, it was 2 years, and Mendeleev had published his table. And the Mendeleev table, or the Mendeleevian table, is what we use today. So Dmitri Mendeleev was a Russian chemist. He too decided to list things by atomic weight, but he did an interesting little thing. He turned each of them into playing cards. So he made himself a set of playing cards. On the top of the playing card, he wrote the name of the element and its symbol. He wrote down what its mass was, so he could lay them in increasing atomic mass. And what he also put on each card was the oxide, the type of oxide that it formed. So as you can see here, Li2O, so 2 lithiums per oxygen. There, beryllium oxide, BeO, 1 beryllium per oxygen, etc. So, and going down, 2 atoms of the element and an oxygen, 2 atoms of the element and an oxygen, 2 atoms of the element and an oxygen. By laying out his playing cards in this way, he could see similarities. There, in this particular column, there were 2 atoms of the metal per oxygen. Here, there was 1 atom of the element per oxygen. Here, it was the ratio of 2 to 3. There were 2 atoms of the element for every 3 oxygens. Here, there were 2 oxygens for every 1 atom of the element, etc. So by laying them out in this way, he actually found that there was a gap here. So he predicted that there should be 2 more elements, 1 here and 1 here. And eventually they did find those elements. This was Mendeleev's original table. This is one variation of it. And as you can see, in this case, he is also going down, whereas we go across. This is another example of a table when it had been converted into a wall chart. And again, you can see now they're going the right way. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, they're now going across as our traditional table goes across. The last modification that was made to the periodic table was done by Glenseymour, a Nobel Prize winner in 1940. He discovered plutonium, and he also discovered several other transuranic elements. And he made one final change to the periodic table. Here he is as an old man with a cut-out version of his periodic table. And it was because of him that we got the shape that we've got today. If you look at these two empty little boxes here, that box is really representing this series of elements here. This box is representing this series of elements here. And I'm going to talk about that in more detail in our next video tutorial, where we talk about the architecture of the periodic table. So now you've really got a good idea of how the shape of the periodic table came along, how it looked, how we as chemists are very eager to discard a law as soon as we find a better one. So thank you for watching this video. Please enjoy our others. Please give us any feedback, and we look forward to hearing from you in the future.